Hello, everybody. How are we doing? This is the Open Observability Talks stream. This is going to be the first one we've ever done. This is essentially a continuation from our Open Observability conference that was run earlier in the year. So we are going to be talking about everything around open source software within the observability sphere. So all the different things like the ELK stack, Grafana, Zipkin, the whole spiel. So hopefully you'll be coming along for us for the foreseeable future as we have people coming in and giving talks, as well as doing things like panel sessions and discussions. If you think of a good idea, feel free to share and we will see if we can accommodate. So the format of these is going to be a talk, discussion, or other around something within open source and observability. And then we're going to have a little bit of a current events piece for the news around observability. So that those of you who don't have the time to stay in the know around everything, there'll be a little bit of just update news around all the different tech, the facilities and societies around them. So that's me giving the introduction. And the first person to have volunteered or being a guinea pig, depending on your point of view, is Jack Neely, and let's add Jack to the stream. Hello, Jack.
Greetings.
So, Jack, you're from 42 Lines, and you're a consultant around observability and, well, operations.
Yes.
What does that entail?
That entails so much, since those fields can be really large. We're looking at sort of shifting the way we kind of approach our consulting business, and sort of taking the SRE, the site reliability angle on things, because that's a lot of really what we've been doing for the past 10 years is doing embedded employees within an organization, usually in their ops team, to bring about things like monitoring, visibility, logs, ELK, databases, MySQL especially, and just general operations and Kubernetes and infrastructure pieces, so that the company at hand can staff up quickly and focus on what they're good at.
Excellent. Sounds brilliant, actually. So your talk is going to be on 5 tips for running Prometheus. Do you want to take it away?
Sure. I will get to the slides here. So a year ago at Monitorama PDX, I did a lightning talk, which this talk sort of grew out of. So it's an expanded version. And it kind of focuses on doing SRE style monitoring with Prometheus and working people through basic PromQL queries and taking those queries and sort of leveling you up and getting folks to the point of doing SLO, service level objectives, and burn rates, and some of the SRE methods on top of your Prometheus. So, starting simply, everyone knows pretty much out of the box how to detect if a service in Prometheus, or an instance of an application really, is up or down. There's a magic up metric. You can pass it a job label to identify which service you're looking for. And if that's equal to 0, then you have an application instance that's down. Except in the cloud native world, no one cares if an application is down. Please don't wake me up. Where we want to move toward is perhaps saying, is there a certain minimum threshold of application instances that are healthy and running? And since up is either a 0 or a 1 per instance, we can use the sum function in Prometheus to sum those together and make sure they're 3, or if they're less than 3, we want to generate an alert. Where we probably want to be in our cloud native world is, instead of doing threshold-based alerting, we want to do alerting based on ratios that are dynamic and that will travel with us as we scale through our journey with our application and our products. we can use the average function to build a ratio, not an average, but a ratio of the number of up and healthy instances to the total number of instances. That's really cool. If that is less than 0.8 or 80%, you know we have a problem. You want to page on call, wake that person up. We've got something we need to fix. Finally, do you trust your service discovery? I don't trust your service discovery. I don't trust my service discovery. One of the fun problems in Prometheus is realizing service discovery failed. There is no data, therefore there's no data to alert on. Pairing the up metric with the absent function is one of the few cases I advocate for folks that I work with to use absent. Absent will tell us if a metric exists or not. So you can use the OR operator and pair the absent function with one of the previous expressions on the screen and build a really robust alert that says, is 80% of my fleet up and running healthily, or do I have no data in my Prometheus and something bad is wrong? Page me. Using the absent function can be a slippery slope. A lot of folks I've worked with have tended toward using absent to figure out, are these important metrics in Prometheus in my system? And that's actually where I suggest folks use unit testing to make sure their code is exporting the metrics they expect. Absent should probably be used in very few cases. So let's level up. If you're using the Prometheus client libraries, you get a bunch of Prometheus metrics for free that you don't have to invent. This is really super handy. There's a lot of useful stuff you get for free this way. One of them is a metric called process start time seconds. And it's really super easy to figure out by using the time function how long an application instance has been up and running. And perhaps if that's less than 5 minutes or 300 seconds in this case, you might want to know that. You might want to have that on dashboard or something. But please don't page me. No one really wants to know that a cloud native app restarted when you're running an entire fleet of them. What you probably want to know is, do we have application instances that are in a restart loop? So there's a configuration error. They can't connect to a MySQL database or something similar, and they're in a restart loop trying to recover. For that, we can use the changes function that comes with PromQL and Prometheus. We can look at the process start time seconds over a range of an hour. And since that metric only changes when the application starts, we can figure out the number of times that there has been changes in that metric value over the last hour. If that's greater than 3, page me, something's gone wrong. But how can we take that to the next level? Really, if I have a Kubernetes node that's not healthy or an instance of an application that's not healthy, I don't want to be woken up. I'll see that tomorrow morning. I'll fix that during normal business hours. I really want to be woken up if I have a large fraction of my deployed fleet in a restart loop. That would be bad. And we can take the middle expression, add the bool modifier, which is a really handy modifier that causes that expression to return a 0 if the expression is false, or a 1 if the expression is true. Without the bool modifier, the expression only returns data for true cases. But since we have that magical 0 or 1 expression in the middle, in the third example on the screen, we can use average to again build a ratio, not an average, but a ratio of the number of instances in that state of continually restarting over the total number of instances. And if that's greater than 0.5 or 50%, half our fleet's restarting. OMG, let's get somebody on the case. So point number 3, leveling up number 3. There can be some convention around using Prometheus and using Prometheus consistently. One of the common pieces of convention that I like to suggest people use and adopt is the build info metrics style. Brian Brazil has blogged about this and mentioned this multiple times. We can check out his blog with some more details. Prometheus itself gives us a really good example of this particular metric. Prometheus exports metrics about itself, of course, and it exports the Prometheus build info metric, which has a bunch of labels that describe the exact version, git commit hash, etc. of Prometheus that's running. And of course, the value of that lovely metric is, as you might expect, 1. So that's great. How can we use those labels to our advantage? Well, there's a neat trick here. Let's look at go memstats alloc bytes, which is a metric that would tell us how much memory, how much RAM a Go process that we're monitoring has allocated. What's the RAM size of that Go process? That would be something important to track. It's a default metric from that client library. Because the build info metric is 1, we can multiply those two metrics together and we get the same value for go memstats alloc bytes. We can also use a trick of the group left modifier to pull to pull labels from the right-hand side and shove them into the left-hand side. So we can actually take the version label from the build info metric and shove it in to the go memstats alloc bytes metric and have that come out as our output of that expression. That is super powerful and should be cheered from on high. One of the unique gems of using PromQL. This allows us to do really fun things like we can compare memory usage of your application per version. So if you're rolling out an A/B deploy of your application, you want to be able to compare, is B better than A or vice versa? So we can do that with Prometheus by looking at the median or the 50th quantile of go memstat alloc bytes per version of our application that we've deployed. And we can do that with a quantile function, 0.5, which is the median. We aggregate out instance, and then we have the memory usage per application version in our deployed fleet. That's super powerful. Leveling up once again, we want to get to the point where we're measuring and monitoring our service level agreements, our SLOs, with Prometheus. And the tool that one would reach to do so in Prometheus is histograms. And histograms are a really powerful data structure for working with percentiles, working with latencies, working with events that are high volume, rapid fire events with Prometheus. The problem is Prometheus's implementation of histograms is not very good. I spoke with some of the folks at Apple who was doing some similar research into using Prometheus and had actually stumbled across some of my own writings. And the folks at Apple had done some studies and realized that using the default histogram setup in Prometheus, using the quantile estimation tools that Prometheus gives you, your estimations are probably 200 to 300% error. And that's not cool unless you do a lot more tuning, and that's not cool. So how can we look at doing latency as an SLO at a much more reasonable way that is much more accurate and that reduces the cardinality of our metrics in Prometheus, which histograms can definitely introduce a lot of additional cardinality. What I'd like to suggest to folks is to follow this pattern. If you've played with histograms before, Prometheus's best practice is to use a bucket boundary for your SLO threshold. In our example here, that's going to be 10 seconds. So your application already knows about the threshold number. That doesn't change. Tell your application what the threshold is. Go ahead and make a metric for it. You'll probably want to reference it later. Make a series of counters. Count the total number of events you processed. Count the total number of events that produced an error. count the total number of events that took longer than 10 seconds, or our SLO threshold, to process. Once we have those counters in place, we can simply build a ratio of the rate of events that took longer than our SLO threshold to process over the rate of our total events, say per day, subtract that from 1, and we can test if that's greater than 0.9 or 90%. That will tell us and alert for us if the percentile of 10% drifts below our goal of 90%. 10 seconds, that drifts below 90%. So that tells us what percentile our 10-second goal sits at. So you can watch where your 10-second goal is in your live metrics. So that's a really fun way to look at using SLOs and alerting off of latency. And the best part, it's accurate. So that takes us to error budgets. If you're measuring your SLO, you're also measuring your error budget. If we look at an SLO of 95% of events are successful for a 30-day period, the other 5% is our error budget. How much of that 5% are you using? Are you using a lot of that and you're really close to breaking your SLO? Or do you have a lot of slack there to be more risky with the new features and new deployments that you're doing? So the question of error budgets is, how fast are you consuming your error budgets? And as we look at doing SLO style alerting with Prometheus, there are two common problems. That's a lot of data if you're looking at 30 days that your Prometheus may or may not have in its TSDB. Perhaps it restarted recently, or you had to reset its storage. If you're scaled up, that can be a lot of data to process in real time. The other problem that's commonly encountered here is that if you have an outage and you break your SLO, you paid your responsible party, you get things fixed. Once you get things fixed, you expect the alert to resolve, right? The SLO alert isn't going to resolve until the next 30-day period because you've broken your 30-day SLO. So that doesn't give you good feedback on if you've actually fixed the problem or not. And then once folks come in during the day, they see the same problem and try to fix it again. So those are common issues that we try to work around with doing SLOs. And alerting based off of burn rates is actually a really unique way to sort of look at that. So what we're doing is we're looking at the rate of errors that we have over an hour or over 2 hours. And we divide that by 1 minus the SLO, 0.05 in our example here. And that gives us the burn rate of how much of our error budget that we're consuming in that past hour, in that past 4 hours. So that puts us in a situation that we can build an alert. Are we burning more than did we burn more than 5% of our error budget in the last hour? And that ends up being relatively simple. We can solve for burn rate because we know we're looking back the last hour. We know our period is 30 days. And we know that we want to alert on consuming more than 5% of our budget. So we solve for burn rate, which ends up being 36 in this case. And we can rephrase the first equation as an alert in Prometheus. Is our error rate for the last hour greater than 5% of our error budget? And that is a super powerful way to alert off of SLO data in Prometheus. It's also explained in the Google SRE books. It avoids looking back 30 days because we're looking at an hour's worth of data or 4 hours worth of data. It resolves very quickly as well. So once you fix the problem, your burn rate based alerts will also resolve. So that's a really interesting way of addressing some of those concerns with doing SLO-based alerting in Prometheus. So some of the takeaways that I wanted folks to be able to walk away from this is Boolean metrics in Prometheus are really powerful. Averages can be misleading, but when you can take that function and build ratios, that's a really handy trick to level up your PromQL skill. Prometheus can easily be used to build dynamic alerting on the health of your applications, usually based on ratios. It's really pretty simple to build those. They're not expensive to execute. Good alerting in real time. Building alerts based on service level objectives or customer experience is really very possible with Prometheus, but there are some caveats that we need to understand and work well to make sure our math is correct and we, the SREs, the operators, get good feedback out of our systems. Using Prometheus best practices consistently can really be super powerful for your organization. And one of the things I like to work with my clients is showing them that they can use Prometheus to track a rolling deploy or rolling canary release in progress and be able to compare live the performance of the old release versus the new release and be able to make nearly instant decisions about how their stack has improved and the health of their overall application stack. So that's what I had prepared. If you like some of this content or interested in doing some embedded SRE work or other consulting, please look us up at 42lines.net or give me an email. We'll be glad to talk with you about that. I also co-host the Practical Operations podcast, which has a lot of similar topics about doing operations and SRE work in sort of a practical sense, rather than just reading the Google books. So come check us out at operations.fm.
Okay then, Jack. Thank you very much. I'm not going to lie. It's 7:52 p.m. here, and it's warm and my brain is melting. So weirdly enough, I could follow along when I wasn't trying to follow the math.
Yes, it's a bit late there in London to expose you to that much math.
Yeah, it's fine. It's the victimless crime of organizing it myself. So, thank you very much. Let's get my banners up. It is time for questions. So we do actually have some on the screen. The first one here is Is there a way to use machine learning or statistical functions to automate the alerting versus manual thresholds in Alert Manager?
So yes, I've definitely done some work before using statistical functions to do anomaly detection in Prometheus. And basic anomaly detection is definitely possible. That's totally another presentation. But there's definitely some work that we can easily do there. Machine learning in Prometheus itself currently really isn't a thing. Usually what I would do there is integrate a client's Prometheus setup with a third-party vendor that takes care of some of the business needs, some of the long-term storage, and some of the advanced analytics that you might want to do with that data. Usually leveraging a vendor with your local Prometheus setup can have some power there. But yeah, doing some statistical modeling with Prometheus is totally possible.
Would you advise for or not doing it? Do you think it's an overcomplication? Do you think it's something that you should be doing just to in the long term, simplify things by having the system create the alerting itself? Or do you think it's something that should be highly controlled and manual? Just a personal opinion.
It always sort of depends. I've been in a lot of situations where folks want to build alerts on every single little thing, and you end up with that kind of cacophony of alerts and the Christmas tree effect. And introducing anomaly detection in that mix usually doesn't make it better. I definitely prefer more customer-focused based alerting. So, if your customers are going to see bad latency, you want to build an alert on it. And that usually simplifies things pretty drastically. And that helps you identify some of those important service level indicators, to use the buzzword, that you really like to use some anomaly detection with. So there are certain indicators that are really key that this becomes useful with, but it's not a generic tool that you can just kind of slap around any metric to get good signal out of.
Okay. And the next question. Ooh, do I use the question I created or the next question from the crowd? Let's go with the next question from the crowd. So this one is not directly related to the specific topic, but Prometheus in general. Does Jack have a background or advice on long-term storage of metric data with Prometheus?
Oh, yes. Again, I think there's a good vendor story here. Building a full-on cluster to handle long-term storage of Prometheus metrics. Say you want to compare trending year over year. How did the outage I just have today that was really big and really major compare to the outage we had last Christmas? I think there's a good vendor story to be had there, because that drastically simplifies what we need to do as an SRE team, as an operations team on site. There are some open source solutions as well. I've worked a lot with Thanos and deployed Thanos in pretty big situations. So there's some additional cognitive burden there. There's some additional overhead. There's some additional care and feeding about making sure that your data stays accurate and mathematically foolproof. But yeah, there are definitely some stories around how to do that.
Okay. Now this is a question from myself. With the storage of it, with the fact that Prometheus has a whole bunch of underlying data stores that can be used to, hold the data. What do you think the best process for actually migrating it into long-term cold storage is? Do you think it's a replica of the exact data store model in a cheap server, or do you think it's actually dropping into a data lake? What would you go with?
Thanos takes a really good approach here. The current database model for Prometheus carves out a block every 2 hours, and those blocks are immutable. So once they're committed to disk, they don't change much. What does change about them is Prometheus will compact them together, which makes querying them more efficient over time. But what Thanos does is it waits until a block is committed to disk, it turns off local compaction, and then it picks up that block on disk and shoves that block into object storage, S3 or GCS. There's a number of object storage formats that they support. That works really well. The history of Prometheus is that it wasn't designed for a long-term durable data store, and doing operations that you need to do to the database to do repair, filter data, to do backups were traditionally not prioritized. Prometheus has definitely made huge strides in that world. There's easy ways to snapshot now. There's a Thanos approach of picking up those TSDB blocks and shoving them around. But that's some of the things that I'm familiar with addressing some of those concerns.
Okay. And here's the question that I wanted to ask, because I'm not actually from a DevOps world. I'm a developer. I'm learning how to be a DevOps person and have been for the last 5 months in my current job. So what about dog fooding? What's the best practices for managing alerting on the Prometheus cluster itself?
Oh, wow. That's another presentation.
Damn it.
I'm a big fan of dog fooding. In some of the large scale clients that I've worked with, what we ended up doing was setting up a Prometheus instance for each team. So each team monitored their main application, or all their applications, with their local Prometheus, which gave them a dashboard of alerts on that Prometheus that they could focus in on their own alerts. I've definitely been focusing in on teaching folks about the four golden signals and the use and read methods about trying to build alerting. Again, that's another presentation, really. There are several schools of thought about how you should build alerts in a standard way for an application, rather than just kind of alerting on every output it emits. So there is some thought that is going on there in the open source world. It's not nearly as commonplace as I would like to see, but starting with the four golden signals, the use method, the read method, depending on which works best, are some pointers to dig into about how to alert on, how to make some techniques to alert on an application that are kind of standard throughout your company. Because having those standard alerts, those standard SLOs through your company gives you a lot of power. There, I kind of danced around that a bit.
You were very, very political whilst being informative.
But you're building a common kit and common practices that you standardize on and try your best to use similarly throughout different stacks in your microservices environment or in your monolith environment, really. Gives you a lot of flexibility and a lot of additional velocity that folks don't realize they have.
Okay. We haven't got any more questions from the crowd, and I've just realized every question I've expanded on has been answered with well, that's another talk. It's starting to sound all Disney World. That's a story for later.
World.
So it looks like I've given you plenty of material to create your next talks for the next year.
Sure. I'll submit another CFP or two.
Ooh, we wouldn't say no to that. So, do you have any last remarks you would like to share with the crowd?
Mike, thanks a bunch for asking me to help you kick this off. I really appreciate it. It's been tons of fun, and I really enjoy participating in the open source world and sort of teaching people how to level up, especially with their monitoring.
Brilliant. Well, thank you very much for joining us on the first one. I apologize that you've been a guinea pig, but you have been the most gracious of guinea pigs the world has ever seen.
I like being guinea pigs. It's fun.
They're fluffy and they're great.
Yes.
Thank you so much. So we'll be saying goodbye to Jack for the moment, and we will be cracking on with the breaking news. And by breaking news, I mean anything that's happened in the last month. It's kind of hard to call it breaking when it happened 3 weeks ago. But it sounded like a fancy little banner I could put up to do the next piece. So, the breaking news. And I need to share my screen, which I should have prepared earlier and completely zonkoed on. Let's go with that one, which is actually going to be me sharing me. Let's do this so I can use my other screen so I can see what's going on. There we go. Excellent. Right. So first up is the Elastic Stack has had a huge amount of upgrades. I swear to any form of deity that Elastic just went nuts and upgraded everything. So they've had upgrades to Elasticsearch, the enterprise equivalent, security. Even Logstash and Kibana have had minor patch versions, and this is not long after the last one as well. So it's a lot. And I would go through some more finite details, but there has been so many of them. It's probably hard. All I can say is they have done a whole scale of releases. So if you currently are running a ELK or Elastic Stack, the 7.x version, it's possibly having a look at it, because there's probably a component in these upgrades that will be beneficial to you in your stack, either through querying performance. Even I believe there has been a small amount of shrinkage in the application size, the JavaScript application size of Command. So have a gander around all that. The next bit is Jaeger has had its 1.18.1 release. Two of the biggest points that have been raised in this one has been the OTel compatibility, which is a huge step forward. Hopefully we'll be seeing some more. The sooner we get to a full my brain, it's late. Sooner we see more, and we've all the better, especially with the steps in OpenTelemetry moving forward towards full specification. So there has also been the Kafka receiver, which I actually can't remember when that was started. But that's been part of this release. We also have a little bit of CNCF news from this month. There's been a whole bunch of people that have joined the project or the foundation as sponsors. Everybody from HP, even the organization I work for, Logs.io, is now a sponsor. So there is a whole bunch of them, but some more specific news. First, Priyanka Sharma has now become the general manager. She comes from the she was the director of cloud native alliances at GitLab. So she's been in and around working with open source software for a long time at varying scales, from all the little guys to all the huge guys. So she's going to be a great asset to driving parts of CNCF's adoption and just making sure everything goes smoothly as possible. And the last bit of news that we've got is Harbor has been graduated from incubation. So Harbor entered its 2.0 release. And for those of you who are unaware of what it is a repository for Kubernetes, allowing you to do things like volume scanning, etc. So you can make sure that you have vulnerabilities checked, etc. on the image storage side of life. So that is some breaking news from the world of DevOps. DevOps and Open Observability. Oh, Lord, I need to do this earlier in the day. So let me stop sharing my screen. Let my big head with its nice level of sweat appear on the front. So thank you very much for tuning in, everybody. We really appreciate it. It has been the first one, and it has been an absolute terror for me. We've had an amazing speaker in the form of Jack, and he's been so gracious and brilliant in sharing his thoughts on 5 tips for application monitoring with Prometheus. I should really have asked him at one point, what was the worst thing he's ever seen? The giant thing we should all avoid. But I completely forgot to ask that during the question time. Whoops. Sorry, everybody. So I have been completely and utterly inept at this, but I hope I've been entertaining. I am your host, Mike Ellsmore. I'm a developer advocate at Logs.io. And just a quick ask. If you found this entertaining, educational, or otherwise, please follow and subscribe, or even like, because that's what the YouTube algorithm likes. We also would really love your feedback. So if you'd like us to do, say, an Open Observability drop-in where we can have a whole bunch of people who are experts or monkeys like me who just mess around with lots of things, and we can help you try and find some solutions. Or if you'd like to just ask questions in general, you can head to our stream, which is twitch.tv/openobservability. You can ask questions on our Twitter, which is twitter.com/openobserve, because only 15 characters, and our website, which is openobservability.io. So if you want to come and ask questions, share your thoughts, suggest what we can do, we really appreciate it. I've been Mike Ellsmore, and thank you very much. Have a great evening, everybody.